In this part of chemistry, we are going to talk about three main points. First point, we are going to talk about crystals and lattice energy. On the second point, we are going to talk about phase diagram. And on the third point, we're going to talk about hybridization. Okay, for the first point, which is crystals. What is crystal? What is crystal? Okay, in general, many substances that we have them in our life. And we're going to take just one example of them, which is salt, which is NaCl, the table salt that we use it in our food. Okay, as we know, the salt is NaCl, right? Which is sodium atom and chlorine atom. They make what? Sodium chloride. Get this one now. If one molecule of NaCl, that means it has one atom of Na and one atom of Cl. Great. If we have now just a piece of salt, a very small piece of salt, as we know it has inside it too many molecules. Then these molecules, now the question, if you take just part of the salt, just the part that is in the tip, if you're of a pen, if you take just salt there, if you go now deeper to see what is inside them, how do you think will they be organized or arranged in or inside this piece of salt? How are they going to be organized? Will they be, I'm talking about Na atoms and Cl atoms, will they be randomly organized? Okay, if you go deeper inside, you're going to see them exactly as this way, arranged. You believe it? Imagine that this is now the salt inside. One small piece of salt, you're going to see inside it, sodium and chlorine atoms exactly are arranged like this. You see? And this is just one part. And imagine this one now is continuous to the left and to the right. It continues. And these ones now represent what? The atoms of chlorine and sodium. Thank you. So as you see here now, this is chlorine and it's a bigger, and here sodium is smaller. As you see this one now is like a network, organized network of how these ionic molecules are arranged inside their lattice. So this one now we call it crystal. This one now we call it ionic crystal. Or crystal, that means it is an arrangement of ions, okay, where the positive ion, as you see, is surrounded by negative ions, and negative ions are surrounded by negative ions, or you can say it is 3D arrangement of what? Of ions. And I hope that is clear now. What is crystal? This is crystal now. Okay, now we have too many different of crystals, of solid crystals. In solid crystals, this is now ionic. It is NaCl, which is Na is a metal and chlorine is not a metal. So metal and non-metal, they make ionic bond between them, as we know. But if both of them non-metals, if the two elements are non-metals, they're going to make covalent solid crystal. And you have other ones that are metallic solids. Oh, so that means we have types of crystals. This is now just one type. Okay, how many types of crystals do we have? How many types of crystals? These ones now are the main types of crystals. And these crystals now, we have atomic solids crystals. So these crystalline solids, atomic solids, is mainly examples of them is the elements of group 18, which is helium, neon, argon. When they are solids, when they become what? Solids. When they become solids, the crystals that they can make, we call them what? Atomic solids. Okay, molecular solids. Molecular solids is like sugar. That means if you take now part of a sugar and you see what is inside it, you're going to see crystal. And this type of crystalline solids, we call it what? Molecular solids. And it is like what we said, sugar. And here we said group what? 18. Group 18. And here for ionic solid, we have taken example like NaCl, right? Good. What about covalent solids? I'm talking types of what? Of crystalline solids. This one is like carbon. Carbon can make many covalent solids. That means where the atoms are shared. Right? We know what is covalent bond. Okay, these ones now covalent like carbon, and carbon can make 3 solids. The carbon itself, it's one element, but it can make what? 3 covalent solids. One of them is what? Is diamond. One of them is what? Diamond. Diamond is carbon, but it is one solid of one arrangement. It is just one arrangement of the carbon atoms. Okay, if the arrangements will be another arrangement, it's gonna be what? It's gonna be what? Graphite. So that means graphite is also another crystal of what? Another crystalline solid of what? Of the same element, which is carbon. And also we have a third one that is called Buckminster fluorine. Buckminster fluorine, this is the third one. So that means we have 3 different covalent crystals of carbon, and this is what is called what? Allotrope. What is called what? Allotrope. That means when an element can make more than 1 crystalline solids. And here the last one, which is metallic solids. Metallic solids is just the solids of metals like Na, like Al, which is aluminum. Aluminum now, if you go deeper to see the solids or the crystal of it, that shape of arrangement, we call it what? Metallic solids. And metallic solids, as we know, they are good conductors for heat and electricity. Okay, now we understand now what types of crystalline solids, and we understand exactly what are crystals in general. Okay, now we'll go just to talk about ionic solid. Just in one case, we're gonna add it. We're gonna add, if we go back just to the first picture here, as we said, this is now ionic what? Crystal, NaCl. Okay, now NaCl, if I have one atom of Na and one atom of Cl, we have now one molecule of NaCl. Good. Imagine now I have 1 mole of ions of NaCl, 1 mole of NaCl, and I want this compound of NaCl, I want to separate its ions. I want to separate the ions of chlorine and the ions of sodium. I want to separate them. I want to separate them what? Apart of each other. I need energy in this case. So the amount of energy, memorize this definition, the amount of energy needed to separate 1 mole of ions, 1 mole of ions from its ionic compound. That means we are talking about ionic compounds. We are not talking about covalent compounds. We are talking about ionic, which is metal and non-metal. So the amount of energy needed to separate 1 mole of ions from its ionic compound is called what? Lattice energy. And keep that in mind. It is what called what? Lattice what? Energy. So this is now lattice energy. Okay, what do we know about lattice energy, and what do we need to remember about lattice energy? Will they ask us what is the lattice of energy of NaCl? Do I need to memorize that? No. Will they give us ionic compound and what is its ionic lattice energy? No. What do we need to remember now is just what is lattice energy, and we need also to understand how can we compare if I have 2 compounds. If I have 2 compounds, how do I compare which one has more lattice energy than the other? That means which one we need to give it more energy in order to what? To separate these ions from its compound. Great. Okay, so now we're going to take here examples. If we go here to the periodic table, and if we remember now what we studied, or just memorize it now, if you go down the periodic table, what happens or what is the change of the size of the atoms? So if I'm talking about this group, for example, chlorine, fluorine, and it's also for all the other groups. So when you go down, what happens now? Fluorine atom is like this. You see, fluorine atom. This is fluorine. And when you go down now, chlorine, well, it's gonna be what? Bigger. You see, then bromine will be what? Bigger. Then iodine will be what? Bigger. So that means if you go down the periodic table, what happens for the atomic size? It increases. Good. Now I'm gonna take as we said, I'm gonna take example of And remember these examples and these ideas. I'm going to take one example of ionic bond. Okay, I'm going to take this element, which is lithium, and I'm going to take it here, L lithium with fluor. Good. And I'm going to take also the same lithium, but with what? With chlorine. So Li with chlorine, you see? Good. And also another Li with what? With bromine. And another one here, it can be for iodine. I can continue or I can stop here. Okay, now, if I'm comparing now, these ones, all these three are ionic compounds. Now, what is the energy that I need to separate 1 mole of these ions from their compounds? I want to separate the lithium ion from the fluorine ion. Okay, which of them I need to give it energy? Which one has higher lattice energy here? Okay, I need you to remember this idea. Lattice energy, it is directly proportional to the size of the charge, of the size of the charge 1 and charge 2, and also is inversely proportional to the radius of the atoms. That means which is the distance between the 2 ions of the ionic compound. What do I mean by that? That means here, if I'm comparing lithium here, I will not compare it because it is lithium in all of these compounds. That means I'll go now to the next atom. Here, the next atom, as you see, is lithium, right? I mean, it's fluorine, and here is what? Chlorine, and here's bromine. And as we know, when you go down these the periodic table, the atomic size increases. Okay, when the atomic size increases, will the lattice energy increases? Well, I mean, will it increase or it will decrease? So remember, it is inversely proportional. So that means if you go down the periodic table now, the size of the atom increases, and in this case, the lattice energy will decrease. So that means as you go down for these ones here, as you go here, that means the lattice energy what? Decreases. So that means if it is decreases, so which one is the highest? So the smallest, the size of the atom, the greatest the lattice energy. So which one is the smallest? It is fluorine. So that means it is the greatest lattice energy. Then next what? Chlorine. Then next with this one. Then next also for, if you want to write what? Iodine, lithium iodide as well. So we understand now how we compare which compound or which ionic compound has higher energy compared to the size of the atoms, and we understand that it is inversely proportional. Okay, this is now one idea. Okay, what is the second idea here? The second idea, what about if they are, or these atomic size, almost the same or same size? In this case, how I know which one has higher lattice energy? The higher the charge in this case of the atom will be the highest. Okay, we'll go to the next point now. We finish this one, just memorize it. We'll go to the second point here. If we are talking about here now, we're going to take this example here, which is potassium and chlorine. And as we know, this is KCl. Thank you. And you're going to take also here calcium and the same thing here, calcium, and here what? Cl2. So in this case now, which one of these two compounds has higher lattice energy? Okay, remember that. Lattice energy, as we said, lattice energy, it is directly proportional with the charges of the ions and inversely proportional with the distance between the two ions. That means the size of the atom. Okay, what do you need to remember here? What is the charge of the potassium? Potassium is in group 1, so that means its charge is positive 1. We know that. And chlorine is in group here, it's going to be negative 1. Here is positive 1, and here is what? Negative 1. And what is the charge of calcium here? As we know, it is positive 2. And here, chlorine is negative 1, but times what? Times 2 of them. So that means which one now will be higher charges? Where are the higher number of charges? Regardless of the sign, just here, for example, 1 times 1 is 1. And here 2 times 2, it's going to be what? 2, that means 4. So that means the right side here is greater by the charge. The charge here is greater than this charge, so that means the lattice energy here will be what? Greater than the lattice energy what here. Again, lattice energy, it has two factors that we need to memorize them. It increases with the smaller size of atoms, in ionic compounds. And also it increases with the increase of the charges of the ionic compounds. Okay, we're going to take another example. We're going to take here, and this is the last example, calcium here and oxygen. This is now CaO. This one is +2 and this one is -2. And if we are talking about this one and this one here, which is what? KCl. Here in this case, which one will be higher lattice energy? Which will have higher lattice energy? Of course, the one with higher charges. Here the charge is +1 and -1, and here the charge is +2 and -2. So which compound has higher charges? That means the right one has higher charges, so that means it has higher lattice energy. I hope you memorize these examples. These examples, the same examples, same compounds. Try to memorize them and try to understand them. Okay, we finished now the first point of the topic of today, which is lattice energy and crystals. And you understand what is lattice energy and when it increases and when it decreases, and you understand lattice energy and type of crystalline solids. Okay, now we'll go to the second point of the topic of today. Okay, what is the second point that we're going to talk about? We said we have 3 points today. We finished the first point. The second point, we said it is about phase diagram. Then in the third point, we're going to talk about what? Hybridization. Okay, in phase diagram, what is phase diagram? This is now what is called a phase diagram. This is now what is called a phase diagram. Okay, what is a phase diagram? What is a phase diagram? A phase diagram, it is just a diagram that it has y-axis. You see, this is y and this is x. X-axis is temperature and y-axis is pressure. Okay, that's it. What else? This diagram, it gives us a clue of how pressure and temperature it change the state of a substance. What's the mean, the state of a substance? That means, for example, here, if I have a container here, and this container, inside it is water. Inside it is what? H2O, which is what? Water. Get these ones now as you see water inside this container. Water in general, as we know, it can be gas, it can be solid, it can be what? Liquid. Get. In this container now, of course, as long as the water is inside the container, that means it has temperature and it has pressure, right? It has temperature and it has pressure. If we measure the temperature in Celsius, okay, and the temperature in kilopascal, okay. If, for example, the temperature was 100, the temperature was what? 100, and the pressure was just 0.6. That means this point, you see? This point exactly where, this is the point, you see? Where the temperature of this water is 100 Celsius and the pressure is what? 0.6 kilopascal. In this case now, I will not tell you, for example, what is the water state. Will you know from this phase diagram that what is the state of water? Will it be gas or liquid or solid? It's gonna be gas. You see, as long as it is in this color, in this area, in this region, that means as long as the point of y coordinate and x coordinate, as long as it is in this color, that means the water is in gas state. Thank you. Okay, if I keep the temperature 100, I keep the temperature what? 100 of this container, okay, and I increase the pressure. What will happen? As you see, it will go like this, right? The points will go like this. Good. If you stop here, like for example 200, okay, that means if the temperature of water is 100 Celsius and you increase the pressure to be around 200 kilopascal. In this case, water will be changed into liquid. And this process, what is it called? What is this process called? We are changing the water from gas into liquid. This is called what? Condensation. So that means the process of condensation is you can keep the temperature as it is 100 and you increase the pressure. In this case, you are making what? Condensation process, which is to change, or operation, which you change the gas into what? Into liquid. Good. And also now we have other points. Yes. Look here now. What is point B? You see, this point B is very important. We call it triple point. Why we call it triple point? Because now water in this container, if I apply the temperature of the triple point and the pressure of the triple point, I'll find that water inside this container, I can see it in 3 states at the same time. That means I can see some molecules are gases and some of them liquids and some of them solids at the same time if I'm applying the temperature to be 0.01 Celsius and the temperature to be around 0.6 kilopascal. In this case, the water will be in 3 states. It's going to be like solid and liquid and what? At gas at the same time. Is that clear, Shabab? I hope it's clear. Okay, what about if I put this point? You see it? This point, you see? This point now, at this point, if the temperature is 100 and the pressure is around 101, you're going to see like the water, it is like you have liquid state and gas state at the same time. I hope that is clear. Okay, now, can I fix the temperature at 0? Look, if I fix the temperature at 0 Celsius and I increase the pressure, you see what will happen? I'll change the water from gas into what? Into solid first. Then I'll change it from solid into what? Into liquid again, you see? So that means just if I fix the temperature as 0 Celsius and I'm increasing the pressure, that means the state of water will be changed from gas into solid, then into liquid again. So you understand what is triple point now, where you can see the 3 states of, and this is now explained for water, but it also works for many other substances. This is what is phase diagram. It gives you just the states of a substance when it is liquid, when it is solid, when it is gas, under just the 2 factors which are pressure and temperature only. This is what phase diagram. That means you are not studying any 3rd factor. You are studying just 2 factors, pressure and temperature, and what's the relationship between them regarding to what? To the state of the substance. Okay, we have also another point here that is here called critical point. What is critical point here? Critical point, that means if the temperature here for water, no need to memorize these numbers, just understand them, to understand what do these points mean and just understand how they change. Okay, if here for this graph, if the temperature is 374 Celsius, good, what will happen now? And also the temperature is around 22,089 kilopascal. In this point, water will be in a critical point. What is critical point? Critical point is the point that after this point, that means if you increase the temperature more than that, or you increase the pressure more than that, you will not see water in liquid or in gas state. It will be in different state, which is like which is called like supercritical fluid. It's going to be like exactly a fluid that is not distinguished to be gas or to be what? To be liquid. That means it's like between. That means it's not classified then as gas or as liquid, and this is what is called what? Critical point. And here now we finished understanding what is phase diagram. What you need to remember about phase diagram is we understand what are the 2 factors. They are pressure and temperature. We understand what is critical point and what is triple point, and we understand that it is related for the states of a substance, which is solid and liquid and gas, based on the changes of temperature and pressure. And here now we finished the 2nd point of today, which is phase diagram. And now we'll go to the 3rd point which is related to hybridization. Okay, what is hybridization? What is hybridization? If we go back to the periodic table, as we know, elements are made of atoms, and each atom has shells around it. Like here, for example, if we take, here boron as element, it has 5 electrons. These 5 electrons in the first shell, you have 2 electrons, and in the second shell, it has what? 1, 2, 3 electrons. But these 3 electrons that are in the second shell now, they have 2 subshells. What are these 2 subshells? It is the subshell S and the subshell what? P. Good. So it is S and P. Good. Now this boron now, when it reacts with other element to make a compound, the places or the shape of these electrons around the atom will be changed. And this is what is called hybridization. So hybridization, it is a change in orbitals of a molecule in order to produce new hybridization. That means new shapes. Okay, we have main shapes of these ones. We need to understand them. This one here, for example, look, we're gonna take here, but before we understand what is hybridization or what is its shape, we need to understand numbers. We need to understand that we have sp hybridization. This is one type, and you have sp2, and you have sp3, and then we have sp3d1, and you have sp3d2, and so on. Okay, we'll stop here. Okay, look here now. Remember that as we know S, how many orbitals are in S? There is only 1 orbital. So S can never have more than 1 as a power. So the power, it represents number of orbitals. So how many in S subshell? How many orbitals there? 1 orbital. Okay, in P, how many orbitals? 3 orbitals. So it can be 1 orbital here. It can be 2. It can be 3 orbitals. Can it be 4? No. Okay, what about D? D, it can be 1 orbital or 2 or 3. So that means now, remember these ones, S, P, you can, okay, no need to remember. Okay, one of you will say, okay, I don't remember what orbitals. Okay, if you don't remember, just memorize these ones. SP, SP2, SP3, SP3D. Okay, memorize these ones as they are. And remember, there is addition for the powers. Here is 1, 1 plus 1. What is the number now if you add the powers? Here, the addition of the powers will be 2. And here, the addition of the powers will be what? 3. And here, the addition will be what? 4. And here, the addition will be what? 5, as you see. And here, the addition will be what? Will be 6. Remember now, SP, it means a type of hybridization. And the number related is 2. The number related is what? 2, which is the sum of the powers. And SP2, the sum of the powers is 3. Memorize that. And SP3, the sum of the powers is 4. Okay, at least these 3, you memorize them well. Okay, now what does this number mean? Because if I understand this number now, if I memorize this number, and I know this number where it came from, I'll understand what type of hybridization is it, SP or SP2 or SP3. I will understand it. Okay, we'll take examples now. This number now, which is 2, 3, 4, 5, 6, these numbers, they represent, keep in mind, they represent number of bonds and number of free pairs of electrons around the central angle of a compound. Again, so the number that is here, it represents the number of bonds and the number of pairs, of free pairs of electrons around the central atom. Okay, we're going to take examples here. We're going to take first example here, which is methane. As you see, this is methane. Okay, methane now, as we know, it is a carbon atom. Good. And carbon atom, we know that it has 4 valence electrons. Okay, these ones now are the 4 valence electrons. Now it will make compound, it will make now bonds by how many hydrogens? 4 hydrogens. And we know that each hydrogen has 1 bond, 1 electron valence, right? So 1 electron valence for what? For each hydrogen. Good. Okay, what's next now? What's next? Now each 2 electrons will make 1 bond. So that means this one now will make 1 bond, will be bond, and here will be a bond, and here will be a bond, and here will be a bond. Is there still any free electrons around the carbon? All the electrons around the carbon are used. All of them are used. Okay, since all of them are used, now I count how many bonds are there now. How many bonds? Remember that. How many bonds now here? Number of bonds here are 4 bonds. If the number of bonds are 4, I go here to these numbers. Where the number 4? This is the number 4, you see? Okay, if it is 4, that means what type of hybridization is it? Of hybridization is it? It is sp3. So as you see here, it is sp3, you see? So how did we understand that it is sp3? We understand it from number of bonds around the central angle. Okay, no problem. We're going to take another example. Okay, we'll take another example like here, like ammonia. Here, NH3. We know that NH3, it is a nitrogen atom, and this nitrogen atom has 5 electrons around it. It has 5 electrons around it. So that means 1, and here is 2, and here is 3, 4, 5. No problem where you draw these electrons around the nitrogen, as long as you draw the sum of them around the nitrogen atom 5. No problem. Okay, here now we have how many hydrogens? Now 3. So that means here I have now 1 hydrogen, and it has 1 valence electrons, and here is 1 hydrogen and 1 valence electrons, and here is 1 hydrogen and 1 valence electrons. Now what will happen? These ones now will make a bond, and these ones now will make a bond, and these ones now will make a bond. So how many bonds now around the nitrogen? Okay, there are 3 bonds. Okay, good. So that means now I have here 3 bonds of nitrogen, 3 bonds around the nitrogen. Okay, is that enough? No, I need to add also. How many free pairs of electrons? I'm talking about pairs. Is there any pair of electrons that is free? Yes, we have a pair of electrons that is here free. So this pair of electrons, I counted 1. So that means 3 bonds and 1 pair of free electrons. The total will be 4. If the total 4, you go here now. Where is the total 4? Here is the total 4. So that means what type of hybridization it is? sp power 3. So you're going to see it here. It is sp power 3. I hope now we understand how to find what is sp power 3. You can take another example. You can take water as another example as well. Here, you take also, if you take water as well, if we take it here, water is oxygen, and around it 6 electrons. 6 electrons, as we know, 1, 2, 3, 4, 5, 6 electrons. And here we have how many hydrogens here? We have just 1 hydrogen here, and you have 1 hydrogen here. Good. And each of them has 1 electron. So that means here we'll have a bond, and here you'll have a bond. Good. How many bonds now around the oxygen in H2O? 2 bonds. Good. And how many free electrons? How many free electrons? How many pairs of free electrons? This is now 1 pair of free electrons, and this is 1 pair. So that means they have 2 pairs of free electrons. This one is 1 pair, and this one is 1 pair. So they have 2 pairs. So plus 2 pairs of electrons, the total will become what? 4. If the total of 4, you go to the 4, you're going to see what type of 4 it is. sp power 3. So that means you're going to see it is sp power 3 for what? For water as well. And I hope that is clear. Even if you take another one here, even if you take this one here, Shabab, you're going to find it that aluminum, it has 3 electrons around it. If I'm talking about this one as well here, you're going to take that aluminum, which is Al, they around it 3 electrons. And these electrons, they make 3 bonds with each atom of chlorine. So that means in this case, there'll be 3 bonds around the aluminum, and there is no free pair of electrons. So in this case, 3 bonds, the total will be 3. Total 3, as you see, it's going to be sp power 2, which is the sum of these powers, which is what? 1 plus 2. And I hope that is clear now. Same thing for other compounds. But you need to remember, usually these ones are very important. This is 1, 2, 3, 4. These ones, you need to memorize them. Okay, we're going to take also N2O. It's the same thing here. If you just put around it, try it to see how many it will be. By the way, it will be SP, but you try it by yourself. It's gonna be what? SP only. It's gonna be like exactly this one. So try to make nitrogen atom, and I understand hydrogen atom, how many atoms around it, and make two of them, and make with put them like N in the middle, and here is another N, and here is O, and make here 3 bonds, and make here 2 bonds, and you're gonna see that how many of them used. Okay, in this case, just if you have a problem with N2O, just memorize it. N2, it is SP. Memorize it, that N2O. It has exceptions. It has exceptions, by the way. Then memorize N2O like what? Its hybridization is SP. Its hybridization is what? Is SP, because it has some exceptions here. So we understand now how we remember hybridization. Okay. But since these ones main molecules and I need to remember, you try, if you want to just save time, and you can memorize. You can memorize that BeCl2, it is SP. You can link it for BeCl, it is 2, so that means the sum is 2 here. And here AlCl3, there is a number 3, so that means the sum here is 3 of the powers. And here is 4, the sum of powers is what? Is 4. Just 4, it works for these 3 ones. You need to memorize it. Okay, now we understand how to get the type of hybridization, which is SP or SP2O. But now how we get the shape? How we get the shape? Okay, look, I can just link it to you an idea if you can memorize it. What is the sum of the powers here? SP, the sum of the powers is what? Is 2. So remember, since the sum of the powers is 2, that means it has 2 ends. 2 corners, 2 ends. So that means the line that it makes 180, it has 2 ends. So that means when the type of hybridization is SP, that means it's going to make what? 180 degrees. Memorize it, that it has 2 ends. Okay, but with the power here now, SP2, what's the sum of the powers? Is 3. So it has 3 ends. 3 ends, it's going to be like a triangle, right? You see? The triangle has 3 what? 3 corners. So memorize that it has 3 corners. Where this is the central, this is Al. You see, AlCl3. This shape now, what does it represent? It means Al, which is aluminum, and around it 3 chlorine atoms. So this is the aluminum atom, and these ones are the 3 chlorine what? Atoms around it. So this is how they give me the shape where? And in crystals, and in crystals, it's going to be this shape. It will take this shape in its crystals. So that means the angle here will be 120 between them, and it makes 3 corners, where here the sum is 3. Okay, here now, as you see, what is the sum of the powers? Here is 4, S1 and P3. So that means it will make 3 ends, 3 corners. So that means remember its name. This is linear, and this is what? Trigonal, and this is what? Tetrahedral. Memorize it. It is 4 shapes, and here's 4. And here, as you see, it's still what? 3, this 4, the sum. So that means, as you see, it is what? 4. But these ones here, it represents the bonds, and this shape, as you see, these ones bonds, here bonds, and here is bonds, and here is bonds, and here now it represents these ones. They represent bonds. And this one, it represents the free pair of electron, the free pair of electron, if you remember it here, this one, how it looks. And this one, as you see, it has 2 bonds and 2 pairs of electrons. So you see how it's going to be its shape? It is called what? Bent for water. And I explained it. We said that water, it has 2 bonds and 2 pairs of electrons. So this one represents the 2 bonds, and this one, the 2 pairs of electrons. And I hope that is clear now. You try to memorize these ones as much as you can, at least these ones now. And question came here for water many times. So you memorize these ones as much as you can, and you can revise them by doing the quizzes related. I remember what we studied today as phase diagram, and also crystals, and lattice energy, and hybridization. And I hope everything is clear. See you in other videos. Goodbye.